Sup guys, welcome back to Physics Aid, and today we'll be talking about one-dimensional motion. One-dimensional motion is a topic of motion in just an x-axis, or a straight line. We'll be covering a lot today, so get out some popcorn, sit down, and enjoy the ride. If you can remember from the previous video, I explained what vectors and scalars were. If you still don't get it, I'll explain again anyway. A scalar is a value with just a magnitude, while a vector is a value with both magnitude and a direction. You'll see the difference once I give some examples. Let's start with distance and displacement. Now, there's a bit of confusion when it comes to distance and displacement, or any other dichotomies we'll talk about today. In your everyday life, you'll probably hear / use the two words interchangeably. But in physics, they mean very different things. The difference between the two is that distance is a scalar, while displacement is a vector. As you can see here, a chicken walks 5 meters forwards and then 10 meters backwards. While the total distance covered by the chicken is 15 meters, the displacement is 5 meters backwards, or -5 meters. Notice that I mentioned the direction of the displacement's value to show that it's a vector. The symbols are slightly different in the sense that there's an arrow over the displacement, and well, there isn't one over distance. Yeah, the arrows are just to show whether a value is either a vector or a scalar. Now, let's talk about velocity and speed. As you may know, the equation for speed is equal to distance over time. However, the equation for calculating velocity is slightly different. I like to call it vectorified. No, trust me, it's a word. Anyway, it basically just means that distance in the equation is replaced by displacement and the speed is replaced by velocity. So yeah, just slap a few arrows onto it and it's vectorified. Velocity and speed are different in the same way that distance and displacement are. While velocity is a vector and has both magnitude and direction, speed is a scalar and has no direction. Let's use the same example and include time. If this chicken walks 10 meters backwards in 5 seconds, what will be its speed and what will be its velocity? Pause the video here and try to figure this out. And we're back. Do you think you got the answer right? Or did you just keep watching the video because you think you're too smart for this problem? Yes, I know. Anyway, if this chicken walks 10 meters backwards in 5 seconds, his speed will be 2 meters per second, while his velocity is 2 meters per second backwards, or -2 meters per second. Again, notice how I mentioned the direction in which the velocity was. Oh yeah, by the way, going off on a tangent here, but in physics we don't use the standard system, like, feet, inches, whatnot. We only use metric, and speed is usually measured in meters per second, not kilometers per hour. Just a heads up. We can use average velocity and speed when it comes to situations when the direction / magnitude of an object changes over time, so that we can find the average velocity or speed. The formula for finding average speed is equal to total distance divided by total time. For velocity it's the same, and again, the distance is replaced by displacement. Now let's say the chicken walked 5 meters forward in 5 seconds, then walked backwards 10 meters in 5 seconds. What is its average velocity / speed? Again, if you want to, I suggest pausing the video here to solve the problem. The average distance would be the total distance covered, 15 meters, divided by the total time elapsed, 10 seconds, so it would be 1.5 meters per second. The average velocity is determined by the total displacement, 5 meters backwards, or -5 meters, divided by the total time elapsed, 10 seconds, so it would be 0.5 meters backwards, or -0.5 meters per second. Essentially, this average velocity would be the exact same thing as moving backwards constantly at 0.5 meters per second. Let's accelerate to the next topic. Yep, you guessed it, we're talking about acceleration. Acceleration is the increase in velocity over time. The formula for finding the acceleration of an object is acceleration is equal to final velocity minus initial velocity, divided by the time taken for the change in velocity. Here, this chicken is currently strutting, strutting is a funny word, forward slowly at 1 meters per second. 3 seconds later, it is moving forwards at 10 meters per second. Once again, pause the video here and try to figure out the acceleration. To put the formula together, the final velocity is 10 meters per second minus the initial velocity, which was 1 meters per second, divided by the time elapsed between the two instants, 3 seconds. Once the formula is done, the acceleration should be 3 meters per second, or 3 meters per second squared. Hold up though, if you don't understand what 3 meters per second squared means, it just means that every second the object will gain 3 meters per second of velocity. Acceleration can also be negative. When this happens, we call it deceleration. An example of deceleration is a chicken going at 10 meters per second, and 2 seconds later, it's going at 5 meters per second. Again, pause the video here, try to figure out the acceleration / deceleration of the chicken. If you use the same equation as before and plug in the variables, you'll get negative 2.5 meters per second squared, which means that every second the chicken will be 2.5 meters per second slower. So in conclusion, acceleration is just increase/decrease in velocity over a period of time. Well, that brings us to the end of another video. One-dimensional motion is a pretty simple concept to understand, so be prepared for more challenging topics in future videos. If there's anything in this video that's confusing to you, or if you have any questions, comment your questions down below and I'll answer as soon as possible. Thanks for watching and see you in the next video.